हेलो दोस्तों, वेलकम टू द केपी एकेडमी। आज हम सॉल्व करेंगे अ न्यूमेरिकल ऑन कूलिंग लोड कैलकुलेशन फॉर अ रूम। सो क्वेश्चन: द रूम सेंसिबल एंड लैटेंट हीट लोड्स फॉर एन एयर कंडीशन स्पेस आर 50 किलोवाट एंड 10 किलोवाट respectively. The room condition is 26 degrees Celsius dryable temperature and 50% relative humidity. The outdoor condition is 37 degrees Celsius dryable temperature and 45% relative humidity. The ventilation requirement is such that on mass flow rate basis 20% fresh air is introduced and 80% of supply air is recirculated. The bypass factor of the cooling coil is 0.15. So based on this data, we have to determine the supply air flow rate, outside air sensible heat, outside air latent heat, grand total heat and effective room sensible heat factor. ये क्वेश्चन मुंबई यूनिवर्सिटी के 2017 के दिसंबर क्वेश्चन पेपर में पूछा गया था फॉर 14 मार्क्स। अगर आप क्वेश्चन को ध्यान से समझे हो, सो बेस्ड ऑन द क्वेश्चन वी हैव दिस फ्लो चार्ट, फ्लो डायग्राम. दिस इज द रूम दैट वी हैव टू मेंटेन एट अ टेम्परेचर ऑफ 26 डिग्री सेल्सियस ड्राइबल टेम्परेचर एंड 50% relative humidity. The outside condition is dryable temperature 37 degrees Celsius and relative humidity 45%. Now, in order to maintain this condition, we are supplying this outside air over the cooling coil. So we get the supply condition indicated by the yes, right? Then there is return air also. This is return air. Out of this return air, 20% is fresh air. This is fresh air 20%, that is outside air, and 80% is recirculated. Okay, so 80% of this supply air is recirculated again and 20% fresh air. So O is 20% and R is 80%. So we get the mixed condition. So that we supply on the cooling coil so that we get the supply condition which maintains the room condition as 26 degrees Celsius DVT and relative humidity 50%. Okay. So based on this data, we have to find out this one, supply air flow rate. What is the supply air flow rate over here? Outside air sensible heat. What is the sensible heat of this outside air? Outside air latent heat, grand total heat and effective room sensible heat factor. Okay. So let us first of all note down what is given in the numerical. Given. What is given? The very first, the data given is what? Room sensible heat and room latent heat. Okay. So room sensible heat, that is given as 50 kilowatt. 50 kilowatt. Room latent heat also given. Room latent heat, it is given as 10 kilowatt. It is given 10 kilowatt. Then we have room condition, that is TDR. Here we have noted that values. So TDR is given to us 26 degrees Celsius, and then relative humidity of the room that we have to maintain is 50%. Then outside condition is also given to us. TDO is 37 degrees Celsius and relative humidity of outside air is 45%. Okay, 45%. Then we have bypass factor also given. Bypass factor, it is given as 0.15. It is given as 0.15. So based on this data, we have to find out all these parameters. So very first thing that we can determine is room sensible heat factor. The reason is that we have room sensible heat and room latent heat. Okay, so very first thing that we can find out is room sensible heat factor. What it is? It is the ratio of room sensible heat upon room total heat. Okay, so room sensible heat upon room sensible heat plus room latent heat. So this data is with us. So room sensible heat is 50 kilowatt. So 50 divided by 50 room sensible heat plus 10 as a room latent heat. So this gives us the value as 0.833. So room sensible heat factor for this given problem is 0.833. Now let us go to the psychrometric chart to solve the problem. Okay. So very first thing that we have to find out is we have to do on this chart is what? We have to mark the point O outside condition and R room condition. Okay. So for the information we have this flowchart over here also. So with this information we can plot the given information on the psychrometric chart. Okay. So room condition is drivable temperature 26 degrees Celsius and relative humidity 50%. So we have temperature here 26 degrees Celsius. So if you go vertically upward, we get the 26 degrees Celsius line. Then 50% relative humidity is there. So this line is of 50% relative humidity. So our point R is nothing but the room condition. Okay. So R is nothing but the room condition. Although it is a reference point that we can use later on, but right now this R point is over here. Okay. Next, outside condition. Outside condition is 37 degrees Celsius drivable temperature and 45% relative humidity. So similarly, 36, 37. So if you go upward over here, we get the line of 37 degrees Celsius drivable temperature and there is a 45% relative humidity. So in between this 40% relative humidity and 50% relative humidity, we get the 45% relative humidity which intersects this point. So here we get the outside condition. Okay, like this. So we can plot these 2 points, I room condition, O outside condition. Okay. Now we have room sensible heat factor. Just now we calculated that. Its value is 0.833. So we have here a scale which is called as sensible heat factor. So on this sensible heat factor we mark the point of 0.833. Okay. So near about 0.833 here we get. So this is the point. Now from this point we draw a line up to the reference point, which is again we have 26 degrees Celsius drivable temperature and 50% relative humidity. So this is the reference point. So from the reference point up to this point that we have plotted on the sensible heat factor line, so we draw one line. So we draw one line like this. So this is yellow color is line is what? Reference line is called as. Now the procedure is what? From this reference line parallel to this reference line and passing through the room condition, we have to draw a parallel line and extending up to the saturation line, right? But in this problem we have room condition as a reference point only. Okay, we have room condition as a reference point only. That's why we just have to extend this yellow color line up to the saturated line like this. So this red color line is nothing but the room sensible heat factor line. Red color line is nothing but the room sensible heat factor line. So as I have indicated over here also. And this one is what? Line joining I and O. That is room condition and outside condition. Okay. Now as you can see the flow diagram here, O condition and R condition are mixing together and we get the mixed condition M. Right? Mixed condition M. Now we have to find out the condition of that mixed air. Okay. Now in order to find out that, we have one equation, and by finding that temperature by using that equation we can find out the location of that mixed condition. Okay. So it will lie on the line joining this I and O. So what is the formula to find out that mixed condition? It is TM, that is mixed temperature, mixed air temperature. Okay. So the formula is MR, that is mass of recirculated air into drivable temperature of the recirculated air plus mass of outside air which is mixed over here and outside air temperature divided by mass of recirculated air plus mass of outside air. Now in this problem we have given the ratio on the basis of mass. So mass per rate basis पे हम लोगों को कुछ data दिया हुआ है. That is, so recirculated air is how much? recirculated air is 80% and there is 20% only fresh air. So MO is we can take 0.2 and MR we can take as a 0.8. Okay, and total we can say 1 unit mass per it is there, right? So based on this we can write the equation as MR. So this becomes 1 because this is 0.8 and this is 0.2. So this total becomes the 1, right? So MR is how much? MR is 0.8. So 0.8 into TDR, that is room dryable temperature. So that is 26 degrees Celsius plus room, no, it is MO. So it is given as 0.2 multiplied by TO, that is 37 degrees Celsius. That is 37 degrees Celsius. So by this calculation, the TM value, that is mixed temperature, we get as 28.2. 28.2 degree Celsius. So when the outside air, 20% outside air and 80% recirculated is mixed together, and the air that we get is at a temperature of 28.2 degrees Celsius, right? Now we have to mark this point M on the psychrometric chart, so which lie on the line joining I and O. So we have 28 degrees Celsius. By marking that point, this is 25, 26 and 27 and this is 28. So we have 28 degrees Celsius dryable temperature. So going upward up to this line, we get the M point like this. So this is the point of mixed air. This is the point of mixed air. Now the thing is that we have to find out the supply condition. When this M point, the air which is at M is now passing over the cooling coil, and that we get the supply condition. Now as we have this cooling coil which has bypass factor, we are not getting the 100% efficient supply condition. Means what? Whatever the temperature of the cooling coil is, that we are not getting outside the cooling coil. Reason is that there is a bypass factor. So in order to find out the supply condition, what we have to do is, we have to draw one line starting from this M point in this direction such that the bypass factor, let me write the bypass factor formula first. The bypass factor, okay, the bypass factor. So bypass factor we have to do, how we have to do? We have to mark a line length of, let me show you that line first because we have to show the points also. Length of M to ADP, oh it's not that, S to ADP divided by length of M to ADP, like this. Okay, so this line, this way we have to plot the line. How it is? We have bypass factor 0.15. So हम लोगों को ये जो लाइन निकाला है हमने, ग्रीन लाइन, ओके, सो ये लाइन इस तरह निकालना है कि लेंथ ऑफ दिस M टू ADP, जहाँ पे सैचुरेटेड लाइन पे टच हो जाएगा वो वहां तक. सो ADP टू M लेंथ एंड S टू ADP, इन दोनों का रेशियो हमारे पास आना चाहिए 0.15. सो द रेशियो ऑफ लाइन S to ADP divided by M to ADP should be 0.15. So by this way we have marked the line starting from this M point like this. On the saturated line, whatever the point we get, that called is the apparatus dew point temperature. It is nothing but the coil temperature corresponding to the bypass factor 0.15. The coil temperature is indicated by this line when the cut on the saturated line. So it's near about how much? 12 degrees Celsius. Okay, so 12 degrees Celsius is the apparatus dew point temperature, and whatever the line that cuts the red line, that is room sensible heat factor line, so that is nothing but the supply condition. When we draw the line it cuts the red line, that is the room sensible heat factor line. So the point at which it cuts is nothing but the supply condition. Okay, so the temperature of that supply condition, when we find out that on the psychrometric chart, it is near about the 15 degrees Celsius. Okay, it is near about 15 degrees Celsius, and the apparatus dew point temperature we can take 12 or somewhere more than that, 12.2, because it's not exactly on the line of 12. So we can take 12.2 degrees Celsius as a ADP. Okay, so let me write those values. We have, I'll write here ADP here. ADP we have is 12.2 degrees Celsius, and we have S condition, that is supply condition, supply temperature TS, it is 15 degrees Celsius, so TS. Okay, so this data we have. Later on we will come to this chart again, but we have to find out next points like this. Let me change the color of the pen. Right. So what data we have now? So we have supply temperature as 15 degrees Celsius, and we have apparatus dew point temperature. So ADP, or we can call it as a coil temperature also. So 12.2 degrees Celsius. Now based on this data we can find out the room sensible heat. Okay, what is the formula to find out the room sensible heat? Room sensible heat. What is the formula that we have? We have formula as 0.02044 multiplied by Vs. Vs nothing but the volume flow rate of the supply air, multiplied by TDR and TDS. Okay, so this is the formula to find out the room sensible heat. The reason is what? Let us draw one diagram here. This is the room, and here we have supply condition. Okay, the supply air is responsible to handle the or absorb the room sensible heat. Okay, so that's why the room sensible heat which is absorbed by the supply air is nothing but we get the value like 0.02044 multiplied by volume flow rate of the supply air multiplied by supply air temperature and room temperature, in दोनों का difference. So this is how we get the room sensible heat. But already we have supply room sensible heat. It is 50. Okay, so 50 equal to 0.02044 multiplied by Vs, which is to be calculated. Okay, then TDR we have, it's 26 degrees Celsius, so 26 minus, just now we got the supply temperature as 15. So if you solve the problem, we get the supply condition or supply volume flow rate as 222.38 meter cube per minute. This is the value that we can find out from this calculation. So very first point that we calculated right now, that is volume flow rate of the supply air, right? So next we have to find out is outside air sensible heat. So next we have to find out is outside air sensible heat. Outside air sensible heat we have to find out. Now we know that outside air is 20% of supply air. Okay, in the numerical it is given that the outside air is 20% of supply air. Okay, so that's why we can say that the volume flow rate of the outside air is 0.2 times volume flow rate of supply air. Okay, and we know the supply air, how much it is? It is 222.38. So 0.2 multiplied by 222.38. So this way we get the value of supply air, outside air supply air as, outside air volume flow rate as 44.476 meter cube per minute, meter cube per minute, that is PO. Now based on this one, now we can easily calculate outside air sensible heat. So we have formula for that: outside air sensible heat. So in this formula we have 0.02044 multiplied by volume flow rate of outside air multiplied by the difference temperature difference between outside air and room temperature. Okay, so TDO minus TDR. So this is the formula that we have. So we have to find out outside air sensible heat. That's why as it is we will write that. So 0.02044 multiplied by VO. That's now we calculated that. So 44.476 multiplied by TDO, that is outside air. It is equal to how much? 37 degrees Celsius. So 37 minus 26 is the room condition. So if we calculate that, so we get the value as 9.99 kilowatt. So outside air sensible heat is calculated as 9.99 kilowatt. So this is the second point that we can calculate. Third one, outside air latent heat. So outside air latent heat. This we have to calculate now. Similarly, we have formula for outside air latent heat. So outside air latent heat calculate करने के लिए formula है अपने पास. So the formula is 50 VO, that is outside air volume flow rate, multiplied by WO, that is nothing but the specific humidity of outside air minus specific humidity of room air. Okay, so this data we need first of all. Okay, so in order to find out this WO and WR, we have to go for the chart again. So here we have O point. Okay, here we have O point and we have I point here, which is nothing but the R point here, right? So corresponding to this O point, we can mark the specific humidity here. Okay, O point, we can mark the specific humidity here. It is just below the 0.018. So we can take as value as 0.0179. Okay, 0.0179. And R value, okay, room air specific humidity. So corresponding to this value, we can take the value as 0.0115. So 0.0115. The reason is the point is in between this 0.011 and 0.012. So we can take the value in between that. Okay. So here we have, let us draw this, let us mark this point. WO, we got the value as how much? 0.0179 kg per kg of dry air. Kg per kg of dry air, and that is room specific heat. It is near about equal to 0.0115 kg per kg of dry air. So let us put those values in this formula. Outside air latent heat equal to 50 into VO. How much is VO? It is 44.476. So 44.476 multiplied by these two values. So 0.0179 minus 0.0115. So if you solve this problem, the equation we get the value as 14.23 kilowatt. That is outside air latent heat. Outside air latent heat. So this is the third point that we can find out. Now we got the outside air sensible heat, we got the outside air latent heat. Now we can easily find out what is the grand total heat. So let us solve for that. Next point that we have to find out is point number 4, grand total heat. Grand total heat. So grand total is nothing but what? Grand total is nothing but total sensible heat plus total latent heat. So first of all, we have to find out the total sensible heat. Okay. So total sensible heat. Now there are two types of sensible heats. One is room sensible heat, another one outside air sensible heat. Okay. So room sensible heat plus outside air sensible heat. Okay. Now room sensibility is given to us in the problem. It is 50. Okay. And outside air sensible heat is calculated by us. So it is 9.99. So total sensible heat is 59.99 kilowatt. Okay. Similarly, total latent heat is equal to room latent heat plus outside air latent heat. Okay. And room latent heat is given to us in the numerical 10, and outside air latent heat, that's just now we calculated that. So 14.23. So sum करेंगे तो मुझे मिल जाएगा 24.23 as a total latent heat. Now grand total heat, we have grand total heat is equal to total sensible heat plus total latent heat, isn't it? So 59.99 plus 24.23. So addition करेंगे तो हम लोगों को मिल जाएगा total grand total heat as 84.22 kilowatt. Okay, 84.22 kilowatt, right? Lastly, we have to find out is effective room sensible heat factor. Effective room sensible heat factor. अब ये क्या होता है? Effective room sensible heat factor. What it is? Actually, the thing is that it is because of the bypass factor. Okay, it is because of the bypass factor, isn't it? Because outside air is actually going on the cooling coil first, and because of the bypass factor, there is some complications, isn't it? So we are not getting 100% efficiency because of that. So that's why there is some bypass factor that is called as effective room sensible heat factor, right? So that is equal to what? Effective room sensible heat divided by effective room sensible heat plus effective room latent heat, isn't it? Now what is effective room sensible heat? What is effective room sensible heat? It's very close to the total sensible heat. The only thing is that we have to consider the bypass factor also, right? So what is the condition here in the total sensible heat? It is room sensible heat plus outside air sensible heat, right? So this is total sensible heat, but because of bypass factor, we are not getting 100% efficiency of the coil, right? That means we are not getting supply condition as a coil temperature. So we have to multiply this by bypass factor, that is 0.215, isn't it? Divided by same room sensible heat plus outside air sensible heat multiplied by 0.15 plus room latent heat plus outside air latent heat. Here also we have to multiply by 0.15 as a bypass factor. Okay. So right now if we put the values room sensible heat, outside air sensible heat and all those, so we get the effective room sensible heat factor like this. So 51.5 divided by 12.13 plus 51.5. So this 51.5, after putting the values of room sensible heat, outside air sensible heat that we have just calculated, So if you calculate this, so we get the effective room sensible heat as 51.5 and effective room latent heat as 12.13. So अगर इसको सॉल्व करेंगे तो we get the effective room sensible heat factor, that is 0.81. Okay, that is 0.81, right? So by this formula also we can find out the effective room sensible heat factor, but also we can find out the same by using the psychrometric chart. So let us go to the psychrometric chart again and discuss over there how we can get the effective room sensible heat factor. Now earlier we got the ADP, supply condition and M condition. जैसे हमने डिस्कस किया था, येलो कलर का रेफरेंस लाइन है, रेड कलर का रूम सेंसिबल हीट फैक्टर लाइन है, एंड जो आपको ग्रीन कलर का लाइन दिख रहा है M2 ADP, दैट इज कॉल्ड एज ग्रैंड सेंसिबल हीट फैक्टर लाइन. एंड नाउ line joining this ADP point, this one, and this room condition point, that is I point here. The line joining ADP and I point is nothing but the effective room sensible heat factor line. So जो आपको ब्लैक कलर का जो लाइन दिख रहा है, that is the effective room sensible heat factor line. अब in order to find out the effective room sensible heat factor, अगर हम लोग इसको एक्सटेंड करेंगे आगे up to the sensible heat factor line, this side, okay, this side. So जो ब्लैक कलर का लाइन है इसको अगर एक्सटेंड करेंगे ये साइड, then up to this sensible heat factor line, so corresponding to the line touches to this scale, whatever the value we get, that is nothing but the effective room sensible heat factor line. तो ऐसा अगर हम लोग करेंगे, so it is near to this 0.801. or we get the 0.81 itself. Okay, so this way also we can find out the effective room sensible heat factor line. Okay, thank you so much.